Our next discussion here is going to be on ideas of things called angles, where, again, hopefully you have a good intuition for what an angle is. We're going to be a little exact in terms of how we describe angles in this class. That we say the intersection of two rays, the combination of two rays, or more generally, the intersection / combination of multiple lines form an angle. The angle, pictured above, something like so, is the amount of rotation that results from the distinction between those two parts, where we can talk about the two sides of the angle, one being what we call the initial side and the other being the terminal side, measuring that rotation between them as so, and we can name the angle in terms of either just the angle itself, as you can see there, notated it as 1, or in terms of the vertex, the point of intersection between the two rays, lines, what have you, and give it the name B, in this case instead for that point B, where the two rays meet. Or we could talk about it in terms of the sets of points, the sets of lines named along the angle as ABC or CBA, where we just have to be careful that we put the vertex in the middle. The vertex is where the angle, I guess you could say, lives. And what we're talking about with angles, as I said, is amounts of rotation. And in some classes, you'll see amounts of rotation given different names, but the most common one, the one you're probably most familiar with, is in terms of degrees, where we say that a full rotation takes 360 degrees. And I'm not going to keep spinning because I will get dizzy and fall down, and that won't help anyone. The unit we use here, degrees, doesn't really have any special, meaningful context. It's just a floating representation of an amount of spin. And for those of you who are curious, the reason why we use 360 has a few different explanations. One comes down to it being a number that you can break down easily multiplicatively, that it has a whole lot of factors. The other that I like more is that it comes from Babylonian mathematics, where the Babylonians worked in the number-based system base 60, and the value 360 actually takes a very similar sort of place in that counting scheme as something like 100 does in ours for representing a complete thing. But talking about Babylonian numbers and other number-based systems is a topic for a different class. Just want to give a little bit of context for maybe where this sort of thing came from, because it's kind of odd that we use 360 and it doesn't come up very many other places. Anyway, now that we have some more sense of what an angle is, what sort of things we're looking at there, and how we can describe them, let's just get a quick example for the sort of thing that we can use an angle to represent. For this, we have the hour. For this, we have that the hour hand of a clock moves from 12 to 3 o'clock. How many degrees does it move? So, in this case, thinking about what happens on a clock as you move from noon to 3, you can see there that it has gone about 3/12, or 1/4 of a rotation. So it has gone 1/4 of the total rotation, where a full rotation, a full spin, as we said, is 360 degrees, where 1/4 of 360 is going to end up being 90 degrees. So we say that the clock hand has moved 90 degrees. That 90 value is 1/4 of the rotation. And from here, we're just going to get a little bit more on how we can classify our angles in terms of things like this, because hopefully, seeing this number, you remember some geometry from even before high school that tells you this type of thing has a special designation. That's what we're going to see.